All right, well, hello everyone. Good afternoon. My name is Arnav Patel, and today I'll be telling you how you can cook with your data, building a recipe for data validation success with Pointblank. So I want to clarify first that I'm not a creator or contributor to the package, just a very humble fan who wants to reframe a perspective on how to use Pointblank today. And also, if anyone from my company is watching, the opinions today are my own. They don't reflect company policy. Cool? Okay. A little bit about me first. I am a quantitative analyst at Synovus Bank. The majority of my work revolves around data automation and risk modeling. However, in my spare time, I do like to cook and read books about food science. I'm better at one of those than the other. You can take a guess at which one. But I learned to cook from my grandmother. She's the one who got me into it. She didn't follow recipes, and she seasoned with her heart in true grandmother fashion. You know, when I tried to be like her and do it that way, very quickly I realized I just didn't have her tact in the kitchen. And this is kind of what I look like. This is a real picture. It's not a meme. This is actually me. And I very quickly realized that I needed some structure or a recipe to succeed in the kitchen. Right? And I experienced very similar feelings when I would try to develop a new data validation framework at my job. And for me, and probably like many others, good cooking is like good data validation. It requires a recipe to succeed. But bad cooking is like typical data validation. Right? It can be unstructured, fragmented, and reactive. Right? Just like using unlabeled ingredients can lead to disastrous cooking. Right, not documenting your work can lead to disastrous data validation approaches. Right, and typical data validation is often used and built on a variety of different libraries and approaches, which can be fragmented and make things hard to follow for other users. And we've all been in situations where you deliver results and you get that dreaded email that says, hey, something just looks a little bit off. Can you check and see what's going on? Right, you realize you made a mistake after the fact. Maybe someone's name was misspelled. Maybe you left a filter out that you should have implemented in the first place. Whatever the reason, implementing these scattered checks are reactive, and they're a waste of time and effort. Right, so what we need is a better data validation approach, one that applies structure, leverages a cohesive toolkit, and proactively finds and prevents data quality issues. Right, and after trying many different things, I landed on Pointblank as that approach. And I'm going to present a Pointblank recipe that helped take my usual unstructured cooking of data to a documented set of steps that serves as a foundation for new dishes. And this is what the Pointblank recipe looks like today. I'm going to be walking through each of those directions and what they look like in practice. All right, so first, let's start by loading the packages and the data we need. Now, I'm a diehard Atlanta Hawks fan. The pullover's not on accident. And I really wanted to use data from them today, but there's no representation for a mediocre NBA franchise, so I had to settle for using Lakers data. All right? So let's just say you've been given a request, right? We want to see who the top 10 highest scorers in a single game are. Right, and think of this result as your final dish, the thing that you want on the plate at the end of the day. Right, and how can you begin to understand the data that you're working with instead of taking a simple glimpse or a summary view of the data? Right, we can do what Pointblank calls scanning the data. Right, and scanning the data breaks down the input table and returns an interactive report. Right, when you scan your data, you get the option to set what sections of the report that you want to see. So here I wanted to inspect an overview, variable specifics, a frequency of missing values by field, as well as a sample of the data. And we can see what that HTML scan looks like here. All right, we get a table overview. We get our table overview, a breakdown of each of the columns, right? We can see here there's opposing team identifiers, game type, specific play type, the period of the play that's occurring, points, coordinates even, and we have a frequency for each for missing values by column, as well as a quick sample. Right, everything that we wanted to see and we identified in that scan data function, we're able to see here. But how does scanning actually improve upon typical EDA? Right, for one, scanning I think has a high knowledge to effort ratio. Right, the information that you get is very rich for very little effort. You can see just how quickly we're able to do that, and it's even quicker to produce. If you're using Positron, you can probably know that the Data Explorer can do some of this work. But I think where Pointblank is a little bit superior is that you're able to assign the scan into a variable, right? I don't know how DataBot's going to fill in, but let's not worry about that right now. Okay. So now that we have our ingredients identified, let's move on to how we can chop and cook them. Right? You can do that one of two ways, either by operating on the data object directly or through the use of an agent. Right? To operate on the data object directly, we first need to look at a typical data validation component, which is the dplyr filter chain. Right? And here we're incorporating a set of filtering criteria for our Lakers 2008 object, right? We've all done this before. You've seen it a million times. I'm not going to teach you what these mean or how to do it, but I want to talk about why it's important in this context. Right? Filtering won't stop data processing if criteria aren't met. What it'll do is just remove rows silently. Right? It will discard them without any sort of error messaging with what you're discarding, and those things could be useful. So it's kind of like throwing out that bag of salad that you kept in the fridge and you swore you were going to eat this week just because a couple of those leaves are bruised. I can't be the only one who's done that. Raise your hands if you've done that. I feel like people are lying. Okay. But we can use Pointblank to address the lack of communication, right, that comes from a typical filtering. And we can apply expectation functions from Pointblank, which are these functions that use the call vals prefix here. And they work very similar to your typical filtering functions, but with a slight wrinkle, a positive one. We can still test our original criteria by default, but Pointblank is going to default to stopping your evaluation once a criteria fails. So you can see the error message that is produced after the call vals GT expectation was evaluated. We take a closer look, and we can see that processing was halted because there's 400 records, or test units that have a point value less than 0. Right? And since these functions are intuitively named and they work similar to our typical filtering, it's very easy for you to upgrade your code. If you're someone who feels like they don't know how to work with Pointblank, or you have all these scripts that already have all this filtering code and you want to convert them, you can see just how easy it would be. Right? The names are intuitive, it's easy to upgrade, and you don't have to spend a ton of effort to incorporate Pointblank in this matter. All right? And getting an error message for failing expectations means that rows aren't silently removed, but it gives us an opportunity to proactively identify data equality issues. All right? And think of the agent. This is the second part of chopping and cooking our data. Think of the agent like a sous chef, right? Just like in cooking and validation, you need someone to assist you and track your steps as you go. All right, so here we're going to create an agent, and we're going to supply it with a data table in our labels. And then we're going to also add a feature that's called action levels. Right? And this action levels are going to flag a rule when a particular condition is met. In this case, the step will be flagged with a stop condition if there's at least one test unit or a record that fails to meet a particular criteria. All right, we can then supply the meat of the sandwich here, which are all your call vals expectation functions. And then what we can do is called interrogation. What interrogation will do is apply all your expectation functions to the data object, as well as print a very pretty report. And this is what that looks like. Right, in this report, you can see how many records have passed or failed each step, or what columns are being evaluated, and if a warning, stop, or notification threshold is met. Right, take a deeper look. In this case, we can see here in step 3, as we observed before, there's 400 records that have point values less than 0, and there's a red circle here that indicates a stop condition was met, meaning that if you were to apply this particular criteria directly to a data object, as we saw before, you would result in a stop of the evaluation. Right? It confirms what we've seen before, just now in a prettier format, and within the context of the agent. Right? What's also very cool is that the report produces an interactive link to download a CSV. This just allows you to save it to disk, not in memory. So it's a very important distinction that we're going to see later. But what we're doing here, right, is building onto applying expectations directly onto the data object by adding a documentation layer to that process. Right, so now that we've chopped and cooked our data, we need to decide how we want to plate our dish. Right, we can do that by a combination of what's collecting and extracting. Right, and our final dish is our results. Let's not forget that. I want that keep that context in mind as we move forward here. We still need to figure out our end result. And to do that, we first need to figure out if the failing tests are full of bad or just bruised ingredients. And we can do that. And to answer that question, we can remember if we saw the report, there was 400 records with point values less than 0. Using the getDataExtracts function and specifying the exact step, we'll return a table of those records. Right here, step 3, indicated by the I equals 3 argument. And since we know we're looking at points, we can go ahead and dig into the distribution of negative point values present, right? Confirming that we indeed see that there's 400 records with the negative 3 points, so they're all the same. And what does that mean, right? We now have to ask ourselves that question. Is this truly bad data, or is it just something that we can fix and retain and ultimately get our final result, right? So let's investigate. Let's get into investigation mode. That's what you look like probably, that's what I look like. All right. And it turns out that there was a data entry issue, and those negative 3 point values were just incorrectly entered 3 pointers. Right? So we fixed the issue by creating a new object, the Lakers 2008 fixed. We supply that back to our agent and run the agent interrogation sandwich yet again with the updated object, and now we get this. All right, you can see here we have all passing steps. Right? And now that we've addressed all the data validation issues and we know we have the data, like now it's about collecting the data that you want to use to move forward. right? So it's about getting what we're going to call the good data and finish processing. Right, to get our good results, we can do what's called sundering the data. Right? Think of sundering as separating the good data from the bad data. Right? In this instance, we're going to get data that has passed all of our validation steps, and we can see what those records look like. All right, just a brief look. Okay. We can now use that set of good data to plate our final dish. This is just processing code to get to the top 10 highest single game scores. And this is what that looks like. Right? We have our list. This is our end result. Send this to your boss, your friends, whoever you want. Right? Okay. It used to be an avocado sandwich behind it. Okay. And so how do these results actually differ, though, if we were to use the filtering chain that we looked at before? That's important. Right. And because the filter process removed rows with negative point values and produced results that, while they looked appropriate, were ultimately incorrect. Because Pointblank informed us of an error and allowed us to make changes proactively, we can see the discrepancies in results here between the two approaches. And this comparison relates back to the example of reactive scatter checks, right? With the normal filtering process, you would have had to go back, figure out what went wrong, implement those filters, and ultimately get to what Pointblank produced in the first place in one shot. Right? It saves you a ton of time and effort. It's easy to incorporate, and I think that's the benefit of using Pointblank in this example. Right now that our dish is plated, we can share it with others. We're going to do that by writing it out to YAML. If you look at Pointblank, there's a ton of different ways to do this. I wish I could talk about all of them. I think YAML is the most informative and the richest and the best option in this context of this recipe, right? Because you've gone through all this work, it should be a shame not to share it with the people you work with or anyone that finds this interesting. All right, so let's take a look at writing a YAML file out. All right, a prerequisite, though, to writing the agent out to YAML is you have to make sure that you supply a leading tilde to your table argument here when you're building your agent out. It's very important, otherwise it won't work. With that condition in mind, right, you can then use the YAML write function, and what it will do is create a YAML file that documents the specs for the agent and the validation steps. Right, for example, you can start to see all the potential values for a valid play type here, hook, layup, pull-up jump, right, a bunch of others. I mean, you may be wondering, what benefit do we get from this, right? We already have a report that documents all of our steps. Well, you can use this YAML file to recreate the agent or report at any time. Right? It's especially helpful in an automated chain of processing, or if you're using like a targets pipeline or something, you can incorporate it to spit out a report and recreate it without having the data loaded in memory. Right? You can also use the YAML configuration to port the agent's build to new data. We're going to touch on that in a little bit. Right. So to completely recreate the agent, right, if you wanted to basically recreate the validation report for 2008 data, you can use the YAML agent interrogate function, and you can see that you get our report. Right, it's confirmed by all the passing tests here. Right, so why gamble when you can YAML? So maybe you work with a team that uses Python, or you have a team with multiple different languages, and since the YAML format is language agnostic, you can share your validation recipe across different teams. Right, if you're curious, the YAML interrogate function in Pointblank for Python takes the YAML config files and returns a validated object with that interrogation applied. And writing and reading our plan with YAML is also valuable to recreate and port our agent or validation plan at any time. Right? It's particularly helpful, though, when you're encountering new data with a slightly different cross-section. Right. And so with that step, we've walked through our core recipe. But the key to a good recipe is ensuring that it can be applied to something else, making sure that it's adaptable, a little bit flexible, right? Setting you a foundation as you approach new projects or dishes. So let's see how it holds up when dealing with a new request. Right, you get a Teams message. Sorry to put Teams messages up. I had audio. I was really committed to the bit, but I feel like that would have been too much. So let's say you get this message from your boss and you need a way to quickly recreate and process the 2009 data. So let's talk about porting that recipe over, right? We mentioned we can use our YAML file to do that in associated functions. So since we're pretty familiar with this data set, we can go ahead and straight to chopping and cooking it up. We don't have to scan it. And the best part about this is the validation plan is going to do the hard work for you and catch anything that would prevent us from accurately getting our list of top scorers again, right? So to port it over, we can use YAML read agent. And what it'll do is it'll pull the agent specs for your 2008 validation plan. But here what we've done is you can go ahead and set the updated table. So we're using the Lakers 2009 object. You can also update the labels to more accurately reflect what you're validating, right? And when we inspect the interrogated results from this function, we can see this, right? We get different failing steps that existed in 2008. right? We can see that there's 163 records with an invalid plate type and at least 1,000 records with an invalid opponent, right? Taking a deeper look at that. And if we want to take a deeper look at just our failing steps here, right, what we can do is use the getDataExtracts function again and pull out all of our failing records to investigate even further. It's important to note, like I mentioned before, that this all failures object is in memory. So you're able to interact upon it and work with it to continue your processing, whereas if you were to just download the CSVs, it's saved on disk. It's better if you just want to export it visually, not what we're going to be looking at deeper right now. But let's take a look at all of our data failures and see if our ingredients are bad or just bruised. Right, we take a look at the plate types and opponents that are triggering failures, and the results are interesting. We can see that there's a plate type called LeBron James, which if you have any knowledge of the subject matter here, you can probably say that that's an invalid plate type. So what we can pretty confidently say is just bad data, right? However, we do see that there's an opponent here that's listed as OKC, which is the Oklahoma City Thunder. That is a valid opponent name, and in fact, they changed locations around the time of this data, so that makes sense to us, right? Let's imagine you have a little subject matter expertise, and you can confidently say that that's appropriate in this context. Right, so one bad and one bruised data. What do we do from now? Right, we want to make sure that we include OKC as a valid opponent, but leave out records of the play type of LeBron James. Right, it's important to know that in a situation, like a filtering chain would have just dropped both sets of failing records, and then you would have had to go back and investigate, when in reality, the records with OKC as the opponent should be retained, and we want to drop those with an invalid plate type. Right, so it gives us that flexibility. We're also able to do it proactively. Right, so as we fix our bad ingredients, we build a new object, all opponents 2009, that identifies Oklahoma City as a valid opponent. Right, and to accommodate this new set, what we do is we use the same method that we did before to port our recipe over, except we remove step 5, which originally used that all opponents object, to now use the all opponents 2009 object, where that includes our updated list of valid opponents. Right? After interrogation, we get this final report. You can see now that the only failing expectation is the one that we expect to fail, right? The ones with the invalid plate types. And we know we don't want to keep those in our final calculations. So we've achieved what we wanted to by using Pointblank. Right. Now we have to separate the good from the bad and get the best part of our dish, right? And work to get our 2009 top scores. So you can see here, same avocado sandwich, and Kobe Bryant sits up top with 61 points. Right. And it turns out our recipe was a slam dunk. So today I hope to have demonstrated the value of the Pointblank recipe to you to understand and validate your data. And it comes from the ability to provide structure, proactive identification and handling of error messages, and a cohesive toolkit, right? Everything we used was contained in the Pointblank package and environment. It's such a rich package with a lot of tools, and I found myself getting lost in what to do when using the package at times. And I just hope today I was able to provide some sort of structure and a path for moving forward on how to use Pointblank to validate your data. Right, I sort of touched on a lot of the basics today, but like I mentioned previously, I'm not the contributor nor the creator. I wouldn't be here without standing on the shoulders of giants like Richard Iannone, Mauricio Vargas, Jun Cho. They built something very powerful, and I just want to thank them. So next steps, take this recipe moving forward, right? Apply this to your next project and approach new things with some confidence when using Pointblank. You can visit the QR code that takes you right to the GitHub page for Pointblank, and thank you.
All right, thank you so much, Arnav.